Solar energy. Imagine the sun as a giant, never-ending power plant in the sky. Every day, it showers our planet with an enormous amount of energy in the form of light and heat. Solar energy is all about capturing this free, clean power and turning it into electricity or heat that we can use. The beauty of solar energy lies in its simplicity and abundance. As long as the sun shines, we have access to this incredible power source. Solar panels, which you might see on rooftops or in large fields, are like sunlight catchers. They're made of special materials that get excited when sunlight hits them, creating an electric current. This process, called the photovoltaic effect, is like magic. It turns light directly into electricity without any moving parts or noise. But solar energy isn't just about electricity. We can also use the sun's heat directly. Solar thermal systems can warm up water for homes or even power large steam turbines in solar power plants. In some countries, people use simple solar cookers to prepare meals, harnessing the sun's heat directly. The potential of solar energy is mind-boggling. In just 1 hour, the sun provides enough energy to power the entire world for a year. As we get better at capturing and storing this energy, solar power could revolutionize how we power our lives, leading to cleaner air, reduced climate change, and energy independence for many regions. Wind energy. Wind energy is like harnessing the breath of the planet. It's a dance between the sun's warmth and the Earth's rotation, creating invisible rivers of air that flow across our world. Humans have been tapping into this power for thousands of years, from sailing ships to windmills grinding grain. Today, we've scaled up this ancient technology to produce significant amounts of electricity. Modern wind turbines are like gigantic pinwheels, some as tall as skyscrapers. As the wind blows, it pushes against the blades, causing them to spin. This spinning motion is converted into electricity through a generator inside the turbine. It's a beautiful example of turning motion into power, much like a bicycle dynamo but on a massive scale. One of the most exciting aspects of wind energy is its potential for offshore development. Out at sea, winds are stronger and more consistent. Massive wind farms can be built without taking up valuable land, turning our vast oceans into clean power plants. Wind energy is not without challenges. The intermittent nature of wind requires careful grid management and energy storage solutions. However, as technology improves and we get better at predicting wind patterns, these challenges are becoming more manageable. Wind power is already a major player in many countries' energy mix, and its role is set to grow even further in our quest for a sustainable energy future.
Click subscribe to this channel to get more topics you love.
Hydroelectric power. Hydroelectric power is like tapping into the Earth's own circulatory system. It's all about harnessing the energy of moving water, turning the endless cycle of rain, rivers, and oceans into electricity. This renewable energy source has been lighting up cities and powering industries for over a century. The principle behind hydropower is beautifully simple. As water flows downhill, pulled by gravity, it carries enormous potential energy. Hydroelectric dams capture this energy by forcing water through turbines, spinning them like giant underwater windmills. These turbines are connected to generators that convert the mechanical energy into electricity. What makes hydropower special is its reliability and flexibility. Unlike wind or solar, hydroelectric plants can produce power consistently, day and night, as long as there's water in the reservoir. They can also quickly adjust their output to meet changing energy demands, acting like a natural battery for the electric grid. But hydropower isn't just about massive dams. Run-of-river systems harness the natural flow of rivers without large reservoirs, minimizing environmental impact. Pumped storage facilities act like giant batteries, pumping water uphill when electricity is cheap and releasing it to generate power when demand is high. While hydropower has significant benefits, it also comes with challenges. Large dams can disrupt ecosystems and displace communities. However, with careful planning and new technologies, we're finding ways to make hydropower more environmentally friendly, ensuring this powerful energy source continues to play a crucial role in our renewable future. Biomass energy. Biomass energy is like recycling the sun's energy stored in living things. It's a versatile renewable source that turns organic matter, from trees and crops to animal waste, into usable heat and electricity. In a way, it's solar energy with a biological twist, captured through photosynthesis and released when we need it. The concept of biomass energy is as old as the first campfire, but today's applications are far more sophisticated. We can burn wood chips or agricultural residues directly in power plants, much like coal, but with a crucial difference: the carbon released was only recently absorbed from the atmosphere, making it potentially carbon neutral over time. But burning isn't the only way to harness biomass. Through various processes, we can transform organic matter into biofuels like ethanol or biodiesel, providing renewable alternatives to fossil fuels for transportation. Another exciting application is biogas production, where microorganisms break down organic waste in oxygen-free environments, producing a methane-rich gas that can be used for cooking, heating, or generating electricity. One of the most compelling aspects of biomass energy is its potential to solve multiple problems at once. It can provide a use for agricultural waste, help manage landfills, and offer a renewable energy source, all while supporting rural economies. However, biomass isn't without controversy. There are concerns about competition with food crops and the sustainability of large-scale biomass production. The key lies in responsible management and using waste materials rather than dedicated energy crops. Geothermal energy. Geothermal energy is like tapping into the Earth's own furnace. Deep beneath our feet, the planet's core is a swirling mass of molten rock and metal, generating immense heat. This energy source is a testament to the raw power contained within our planet, quietly warming the ground beneath us and occasionally bursting forth in spectacular volcanic displays. Harnessing geothermal energy involves drilling deep into the earth to access hot water and steam trapped in underground reservoirs. This heat can be used directly for warming buildings or greenhouses, or it can be converted into electricity in geothermal power plants. In these plants, steam drives turbines connected to generators, much like in conventional power stations, but without the need for burning fossil fuels. What makes geothermal energy particularly attractive is its consistency. Unlike wind or solar, geothermal power is available 24/7, regardless of weather conditions. It's also incredibly space efficient. A geothermal plant can produce as much power as a coal plant in a fraction of the land area. However, geothermal energy isn't available everywhere. It's most accessible in geologically active areas, like the Ring of Fire around the Pacific Ocean. But advances in technology, such as enhanced geothermal systems, EGS, are expanding the potential reach of this energy source. EGS involves creating artificial reservoirs by fracturing hot dry rocks and pumping water through them, essentially manufacturing geothermal resources where they don't naturally occur. While geothermal energy currently provides only a small fraction of global electricity, its potential is enormous. As we continue to develop and refine geothermal technologies, we're learning to better harness this vast, clean energy source sleeping beneath our feet. Ocean energy. Ocean energy is like harnessing the heartbeat of our planet. The vast, restless seas that cover more than 70% of Earth's surface hold an immense amount of energy in their waves, tides, and temperature differences. This renewable source represents one of the last great frontiers in clean energy production. Tidal energy taps into the regular rise and fall of ocean levels caused by the gravitational pull of the moon and sun. Imagine giant underwater turbines spinning as water rushes in and out of bays and estuaries. These predictable tides offer a reliable source of power, unlike the intermittent nature of wind or solar. Tidal barrages work like dams across estuaries, while tidal stream generators operate more like submerged wind turbines. Wave energy, on the other hand, captures the power of surface waves. Various ingenious devices bob up and down with the waves or use the pressure changes as waves pass over them to generate electricity. It's like converting the ocean's constant motion into a never-ending source of power. Another fascinating form of ocean energy is ocean thermal energy conversion, OTC. This technology exploits the temperature difference between warm surface waters and cold deep waters to drive a heat engine. It's particularly promising for tropical regions and could provide both electricity and desalinated water. While ocean energy technologies are still in their infancy compared to other renewables, they hold enormous potential. The energy contained in the world's oceans could theoretically meet all of humanity's power needs many times over. As we continue to innovate and overcome challenges like corrosion and marine ecosystem impacts, ocean energy could become a major player in our clean energy future. Hydrogen, when produced using renewable energy. Hydrogen, the simplest and most abundant element in the universe, represents a fascinating frontier in renewable energy. When we talk about hydrogen as a renewable energy source, we're specifically referring to green hydrogen, hydrogen produced using renewable electricity to split water molecules. Think of hydrogen as a versatile energy carrier rather than an energy source itself. It's like a clean energy Swiss Army knife. It can be burned directly, used in fuel cells to produce electricity, or utilized in various industrial processes. The magic of hydrogen lies in its clean combustion. When burned or used in a fuel cell, the only byproduct is pure water. The process of creating green hydrogen starts with renewable electricity, perhaps from solar panels or wind turbines. This power is used in a device called an electrolyzer, which sends an electric current through water to split it into hydrogen and oxygen. It's like reverse electrolysis, the experiment you might have done in school science classes. One of the most exciting aspects of hydrogen is its potential to solve the intermittency problem of renewables. Excess solar or wind power can be used to produce hydrogen, which can then be stored and used when the sun isn't shining or the wind isn't blowing. This makes hydrogen a form of energy storage, helping to balance the grid and make renewable energy more reliable. Hydrogen also offers a path to decarbonize sectors that are difficult to electrify directly, such as long-haul transport, steel production, and high-temperature industrial processes. As we continue to scale up production and improve efficiency, green hydrogen could play a crucial role in our transition to a fully renewable energy system. Photovoltaic solar panels. Photovoltaic, PV, solar panels are like leaf-like structures for our technological world, harvesting sunlight and converting it directly into electricity. These marvels of engineering embody one of the most elegant solutions to our energy needs, silently producing power with no moving parts, no emissions, and minimal maintenance. At the heart of each solar panel is a collection of solar cells, typically made from silicon. When sunlight strikes these cells, it knocks electrons loose from their atoms. This phenomenon, known as the photovoltaic effect, was first observed by Alexander Edmund Becquerel in 1839, but it took over a century for the technology to become practical. Modern solar cells are sandwiches of specially treated silicon layers. The top layer is designed to easily give up electrons when struck by photons of light, while the bottom layer eagerly accepts these freed electrons. This creates a flow of electricity that can be harnessed and used to power our homes, businesses, and even entire communities. What makes PV technology truly revolutionary is its scalability. From tiny cells powering calculators to vast solar farms spanning acres, the basic principle remains the same. This flexibility allows for diverse applications, from off-grid solutions for remote areas to integrated building materials that turn entire structures into power generators. As efficiency improves and costs continue to fall, PV solar panels are becoming increasingly competitive with traditional energy sources. They're not just an alternative anymore, but a mainstream solution that's reshaping our energy landscape. With ongoing research into new materials and designs, the future of photovoltaic technology looks brighter than ever. Concentrated solar power. Concentrated solar power, CSP, is like creating a solar magnifying glass on an industrial scale. This technology harnesses the sun's energy not through photovoltaic cells, but by using mirrors to focus sunlight onto a small area, generating intense heat that can be used to produce electricity. Imagine a field of mirrors, all perfectly aligned to reflect sunlight onto a single point atop a tall tower. This point, often a receiver filled with a heat transfer fluid like molten salt, can reach temperatures of over 1000 degrees Fahrenheit 538 degrees Celsius. This scorching heat is then used to boil water, creating steam that drives turbines to generate electricity, much like in a conventional power plant. What sets CSP apart is its ability to store energy. The heated fluid can retain its temperature for hours, allowing the plant to continue producing electricity even after the sun has set. This overcomes one of the biggest challenges of solar energy, its intermittency, making CSP a reliable source of renewable power day and night. There are several types of CSP systems. Besides the tower design, there are parabolic troughs that focus sunlight along a pipe running their length, and dish systems that look like giant satellite dishes. Each has its advantages, but all share the core principle of concentrating sunlight to generate heat. CSP plants are typically built in areas with high direct solar radiation, like deserts. While they require significant upfront investment, they can produce large amounts of power with zero fuel costs and minimal environmental impact once operational. As we continue to refine this technology, CSP could play a crucial role in our transition to a clean energy future, providing steady, reliable solar power on a massive scale.